Welcome. Welcome to Wharton Moneyball. Welcome to a full hour of sports analytics here on the Wharton Podcast Network. This is Cade Massey hosting this week's show, along with two of my longtime collaborators, colleagues, and good friends, Adi Wyner and Shane Jensen. Adi showing up from overseas and very late in the day, as he's been doing the last couple of weeks and will for a couple more. Shane from Philadelphia. And Eric is having some technical challenges, and he may slide in here. He may not slide in here. We're going to run the show the way we have been running it more weeks than not lately, and that is have a guest here for the first half, and then we'll do open lines in the second half. It's a terrifically interesting time of year. This is like championship time of year. There's no more championship-rich moment in the year than probably this week. So we'll dive into that in the second half of the show. In the first half of the show, we have a guest. Greg Bond is here. Greg is the Chief Investment Officer at Man Group. Man Group is one of the world's largest alternative asset managers, and Greg's been there for some time. I met him first years ago when he was head of R&D for one of their subsidiaries, Man Numeric, I think, but he is their CIO now. He is also head of Americas for Man Group, and he's the portfolio manager for their flagship multi-strategy fund. He's typically based in Boston. He is based in Boston, typically in Boston, but he's in London, joining us from London. Greg, welcome to the show.
It's great to see you guys. I really enjoy this. This is always find a lot of sort of analogies between sports and investing, and sometimes it's a lot more fun to do the sports part, to be honest. So it's all good.
Well, we're impressed that you do anything in addition to the job that you have with Man Group, but we're glad you do. It should be said, and we should find out a little bit about this. My impression is that you've done a little bit with Major League Baseball. At least a number of years ago, you got involved. I'm not even sure if I'm allowed to say what team, but you were a little involved with one of the teams.
Yeah, with Red Sox, I reached out. I was working at Numeric at the time, Man Group, and reached out to Tom Tippett, who was in the alumni database, wondering if I could do some kind of sabbatical from my day job. And he said, sure, come on over. And I was an intern punching my little card every day, working on their draft strategy. So they had a bunch of these draft reports from the scouts, and could we turn them into something quantitative? And then I didn't quite realize until the very end, at the last day, I showed up to present to everybody, and they brought in Bill James. Apparently they given him the same data, but unfortunately he hadn't done the work yet. So we couldn't go head to head. But then he wrote me a memo later telling me how wrong I was on a bunch of stuff, which is great. And we had a good time, but it was good to just all of a sudden be in that room and, kind of have a little bit of a head-to-head going on. So it was good.
Was Theo Epstein running the team in 2011?
2011 was the famous fried chicken in the dugout stuff, where when I joined, they had a 99% chance of making the playoffs. And when I left, they hadn't made the playoffs. So I don't know if there's causal inference or correlation or whatever you guys want to call it. But that's when Theo then ended up going to the Cubs, and there was kind of a reshuffling over there.
Okay.
But I was just a lowly intern. It was fine.
It's you're
laying the seeds for the World Series 2 years later.
Yes, I take full credit for that.
There you go.
Yeah.
Now we found the proper causality.
Right.
We're having Greg's not a typical guest for us. He's not working for a sports team, even though he has that experience. But he is writing interesting papers. So he shared with us a few months ago some work that he's done on trying to identify skill versus chance in sports and across sports. And he explicitly builds on our friend Michael Mauboussin's work. Michael wrote the book, The Success Equation, some time ago now, 25 years ago, 20 years ago. And Greg's going to build on that. Michael's been on the show. He's been a while, but Michael's also in the financial services space. He's also kind of moonlighting as a sports analyst. Here's Greg writing academic quality papers, multiple. We thought he was going to send us one paper, sends us two papers, while holding down, this ridiculous hedge fund manager job. I don't know how you do it.
No, it's great. And Michael Mauboussin's work there, I'm trying to emulate that. I think, going back to tying in financial services and invest in sports concepts and, going back and reading that book, that was sort of, everybody had to read that book that was in investing, because it's just such a core. And you talk about it here on the floor. Even people that are much younger than myself will have heard and read about the book. So really influential. Part of it was just going through that book and looking at it, and then getting re-excited about the space. Just there was a paper that came out by Jurdy and Newman at the end of 2024, and they had done some Bayesian stuff around the Bradley Terry model. And paper was kind of cool because it had sports, the depth of competition in sports on one axis, and then like animals and like dogs and sort of there's major depth in the natural markets, if you will. But then sports was always very constrained. So that got me excited. And then the nice thing is they had put a nice Python package together. So I was able to get that going, and I needed our CPUs here at Man Group to run some of those Bayesian. I think I oversampled. I'm sure if we talk about some of the
Oh,
details, but I cranked up
geez.
40,000, 4 samples at 10,000 each. So I had kind of these 4 climbers going. So that was part of it. And then the other thing that allowed me to do it over COVID, as my COVID break, I just decided to collect as many game by game results for as many sports as possible, going back as far as I could. And part of it is in just my philosophy. I thought there hadn't been a lot of work about cross sports analysis. I guess people
Yeah.
have gone very deep into baseball or NBA. And I thought there might be something interesting if I just took some basic techniques like Bill James's Pythagorean theorem, whatever it might be, and just apply it across sports, and maybe I would learn something that way. So that started
Right.
that. So the minute I had that data, then I read the paper, that the Jordy Newman paper. I had the Python package. I had to get a little help from our tech folks to get it all installed, and then I just cranked it over Christmas, the Christmas holidays at the end of
As one
2024.
does, as one does.
No one was on the server, so I felt like it wasn't too bad. It wasn't crowding out real work. And then essentially, with the development of some of the large language models and Claude, they hadn't contemplated, some Davidson model and sort of the ties and the home field advantage and stuff in their basic model. And since I was doing things like English Premier League, and I knew the home field advantage could be pretty profound and affect maybe your estimates of competitive depth, sort of making mistakes, that I thought
Yep.
if I could just use Claude to say, hey, here, add the Davidson model, add these other things, and it actually built it pretty quickly for me. And
Okay.
then I kind of cranked that out. So then I had a full working paper from that, just from the estimation. So looking at competitive depth in markets, in
Yep.
this case, sports. And then the final point, because I built a season simulator for every league, right, using, like, let's say the 2024 schedule, I was able to have Claude come in and help me optimize that and make that a little quicker. So I could take depth of competition, sort of model the league, and then simulate the league over the actual season, so I could translate from kind of single game action into what it meant for end of season sort of relative rankings. And so the way I was going to originally set this up for our investor base is, hey, a lot of our job is to find portfolio managers with skill, right? And one of the ways you do that is, you want to look at their track record, but are there other things that you can look at, entry exit skill, other things that aren't just the pure sort of realized track, in this case, realized wins. And so just thinking about that as a framework, and then people get the sports. And the other nice thing in our space, there's probably, in our global reach at the company, of the 16 sports I looked at, there's probably at least one fan in the audience for each one of those, right? So it sort of is a no-brainer. You can't just do one league, right? Because people get very frustrated. So you have to, the breadth also help from a marketing
You got
perspective.
pretty broad, like Super Rugby or something down in the South Pacific. I'm just
Yep.
like, that's getting out there. But you looked, I mean, you went, not only all the North American professional, but also down into collegiate basketball, men's and women's. You got 14 European soccer leagues. So you did a nice canvassing. Let us start at a high level and
Sure.
and check my understanding. My impression is, again, so kind of riffing off Mobison. I'm jumping over. I'm sure I'm jumping over lots of academic references since Mobison, but let's just start with Mobison. The way you write it, I believe, is Mobison fundamentally wanted to say which sports are more skill based versus chance based as a single characteristic. And you come in and say, well, I mean, technically, there's two main things going on here. One is the fundamental chance nature of the sport, the competition, but also how compressed are the teams in their abilities. And the more compressed, then it's going to look more like chance, even if it may be a very skill based exercise. And then the more spread out they are, the more depth, the less depth there is, the more diagnostic these games will be. And so you're saying we really ought to technically separate these things. But then, you find that they basically don't separate. This is the frustration, I suppose. So you do some real nice modeling, but then in the end, you're like, well, you can't actually separate the chance nature of the sport from the heterogeneity of the quality of the team.
Yeah, I think so there's a metric that he uses called contribution of luck, which is sort of the variance of a coin flip, right? If your league was completely random, what would you expect to see in the cross-sectional variance of team winning percentages, right? And so on that metric, NBA looks really, really good. There's not a lot of luck involved, and then you kind of go to the other extreme. And if you actually run that, and I did this looking for that because I had this long history of data, it's actually time varying. He talks a lot about it being sport specific, but if you go back to the equivalent of the English Premier League in the early 1900s, it's like a random number generator back then. You think baseball's bad, English Premier League, First Division, pre-World War I is really random.
Is that
So
right?
some of it felt not so intrinsic to the sport, but maybe about the competitive environment. And I thought
Yeah.
that was a bit missing. And if you actually do some work, and there's a couple of papers that came after the Mobison book, that you're not quite completely controlling for sample size and the dispersion effect.
Yeah. Okay.
And so the reason NBA looks really good in that particular model, and what ultimately you see, is that it's got good depth, kind of in the middle of the pack depth, but they also play 82 games, right? And NFL is very wide, but they don't play a lot of games. And Major League Baseball is very narrow, but they do play a lot of games. So you can
Real quickly, Greg, you said middle depth, wide depth, narrow depth. Elaborate what you mean by that. Because you just
so just a measure of how
major.
how dispersed the talent is in a given market, right? Or a given league. So some of the basic models assume a normal distribution of talent, let's say, and then what's the standard deviation of that talent would be one way to think about that.
And just to re-summarize what you said baseball's on that dimension, baseball's kind of, you said basketball's kind of in the middle. Professional football has greater spread, and at college even greater again. And then baseball is the most compressed, just in terms of distribution of talent within.
Correct. And over time, it's gotten narrower and narrower.
Okay, so we have the basics on the table.
Okay.
But let me get just one more basic on the table. Because Greg goes through this exercise to say, basically, a win in baseball reveals the percentage signal in a single win in Major League Baseball is like 1.7%. It's 98.3% noise and 1.7% signal. And then he does the same thing for all the other sports. But then you stack it up, baseball plays 162 games. So by the time you get that sample size, you hit more signal. But you can do things like, okay, at what point in the season do the team's records have more signal than noise? Very helpful way to compare these different leagues. And you do that for all four major North American sports.
And I got that idea from Tom Tango, actually, in some of his original way back. And I think Michael used a little bit of that as well when building his metrics. So yes, it was nice to have that come out to be consistent.
Well, let's just put that observation on the table, and then we'll open up to questions, because I want our listeners to understand that that's in some ways the most practical implication of all of this is, okay, how do the leagues compare on this very important thing? And one thing you need to do when you do that is to consider how long the seasons are. So you reach this 50% point at different places in the different sports, but then you have to translate that down into the percentage of the season. So MLB, NHL, NBA, and NFL, you need 69 games in baseball to get to the 50% signal. So we're saying the record in baseball, Major League Baseball, after 69 games is half signal, half noise. And that's 43% of their regular season schedule. NHL, remarkably to me, this is remarkable, 36 games on NHL, which is also 44%. So at the same point in the calendar, the NHL, their diagnosticity of a game and their sample size, their schedule match up with baseball in that way. But contrast that with the two others. So for NBA, 14 games into the season, you've got as much signal as noise in the record. That's only 17% of the season. So this is everyone's sense that basketball season is too long. And then for the NFL, it's 12 games, which isn't that much, but it's a big fraction of their season. It's 71%. It's of the major American sports, it's the deepest into a season that the record actually captures 50% of the signal. Okay, with those basic facts, Greg, do I have that roughly?
And there's some basic, test theory about that and how you take a correlation, sort of the correlation between outcomes and talent, and then what that would look like over the course of a season, Spearman-Brown correlation. There's some math behind it, but yeah, basically that's the idea, that you've got this ultimately you care about the final season correlation between the talent of your team and what actually is the record. And that can be manipulated either by really high accurate sort of game outcomes, or you play with a lot of noise in the games, but you play a lot of games, basically.
Right. And then the other factor is how many teams you have. So you find that the chance of the best actual underlying team reaching the number one spot is lowest in collegiate basketball, because there's like 230 teams or whatever. So all these things can combine you could, if you wanted to, construct like optimal tournament, speaking more broadly about, regular season playoffs or whatever, if your goal was in fact to crown the best team. Anyway, okay, we've got some questions from Shane, and I think Shane was first. Shane.
Well, I guess just on a methodological issue, you have this depth of competition parameter that's pretty important, obviously, to this entire modeling enterprise. But with all these kind of models, as you sort of said, you're assuming kind of symmetric talent distributions throughout. And I guess my question is, if you thought about it, if you instead actually modeled like non-symmetric talent distributions, and I think we probably all think talent is probably not necessarily symmetric. Would that kind of is that depth of competition parameter kind of capturing the extent to which these talent distributions are skewed, and there's only like a certain percentage of top teams that have all the talent? Like, I kind of feel like you're maybe getting that depth of concentration parameter is essentially capturing what is actually inherent skewness that's not being captured by your model in the underlying talent distributions.
So I got concerned about that. There's a couple of other papers where you can assume equal distribution of talent, and you can kind of derive a lot of interesting closed form stuff. But rather than kind of go down that route, I gathered additional data, which is not in the paper, which I think I'm eventually put in, where I went to almost all of the leagues and I got money line odds from the betting markets to use kind of a model free sort of how does the market price dispersion? And from that, you can sort of do it in log odds space, and they can talk about all the kind of technologies around it, but essentially change it, taking money line into a probability that team A beats team B. And then you can look at the dispersion of that. And I calculated that, and it lines up almost perfectly with the bottom-up analysis that I did through the assumption of the, kind of the Bradley-Terry assumption of normal distribution. So I would say it's not terrible. It's not perfect, but I think for the data that I had, none of the conclusions change. And, in baseball in particular, I think a given game, you'd expect it to be very tight, depends on who's pitching, those kinds of things. But that data set was a really interesting data set that took a while to download. But and I can only do 2021 to 2025, but every single game across all those leagues, and probably monitoring 40 to 50 bookmakers. You can kind of aggregate it up. So it's pretty powerful, cool data. There's a company that does this, and I was able to download all that.
Greg, we skipped over the fact that you said bottom-up model-based evaluation, because you're in the course of this analysis estimating strength parameters for every team in your data set across all of these leagues, a single one for each season. But that's what you're talking about. And now you're saying, I can do it that way. Or right. I can go out to the market and get information. I can infer those underlying strength parameters from market information top down.
Correct.
And you're saying they coincided very well.
They're pretty close.
Well, I guess I have too many, so I'm going to have to start with, I guess I'll start at the bottom. I mean, I actually wrote a paper on measuring luck and skill sort of in general. And basically two components has to do essentially how much learning does it take to go from the bottom to the top? And you essentially divide up that path in levels. So from the bottom to the top, there are levels. And a level is where the team at one level higher than the one below it consistently beats them. And so that's a very loosey-goosey idea, because it's very hard to make perfect sense of that stuff. So that leads to the question, and this is how I always like to think about skill versus or compression of talent is really what we're talking about here, because it's all skill-based. There's very, very little actual dice-oriented luck in this kind of sports. Although there is how we describe that luck is complicated, right? I mean, if you think about it, what is luck, right? We just saw a penalty shootout that determined the Champions League. Is that luck? Is that skill?
Oh, yeah.
And I don't want to get into that. That's sort of a sideshow. But the questions that I always ask about sports is, and which seems to me to summarize it, is if you look at the best team versus the worst team, and they played each other, what's the probability of the best team winning? And then look at the best team versus, say, the average. Let's say look at the best team versus the first quartile, and sort of look at the dispersion and the probabilities. And we all know that for baseball, for example, that's much tighter. You don't see even the very best team playing the very worst team still at most might have an 80% chance of, probably even less, of victory. But we know in basketball, best against worst, it's probably nearly 99% chance of victory. And then in football, it's more compressed slightly. And that's kind of a way to understand how much skill and luck there is in the game because of that. And that directly translates out into questions like what's the probability that the best team wins the title at the end. But that, of course, then sneaks back to Shane's question, which is normality is not going to really work for if you have an outlier. They're gonna run up the score. And then I guess those are all statements. I'll just sort of finish with a question, which is: at any point in your analysis, do you look at the actual outcome of the game other than who won and who lost? And doesn't that reveal information? So if for example, if I destroy my opponent, doesn't that give me inside information?
Oh, absolutely. I did not do it. This was just the pure outcome. Clearly, you are throwing out a tremendous amount of information. It's funny. In our high school sports leagues in Massachusetts, they don't even look at wins and losses to calculate playoff ranking. It's all about goal differential or point differential and strength of schedule, right? So clearly, in those very unbalanced situations, that's a much more accurate predictor of who's going to do well in the playoffs. So this was clearly, and you could definitely augment the data. My simple augmentation was just really the home away thing. That was not in there. That was a meaningful variable that was missing. But yes, you could probably move things into goal differential or point differential, which would be much more powerful. Your scaling question is very interesting. There is embedded in the paper that I'm borrowing from the Judy Newman paper about what the variance is of two teams playing each other, and it's about 1. You just assume it's 1. So that coefficient of depth has a scale assumption into it, which then allows you to kind of think about, so it's sort of a relative ranking, but not in some sort of weird absolute sense, though it does seem that teams typically, or so a lot of leagues have a competition level of about 1, as it just turns out. But I think that was more of an outcome that was a bit random, but that there's a scaling assumption for sure. And again, I will show you the normality assumption, I think, is not terrible. I mean, if you look at it, and there are certain situations, and the Dodgers, et cetera, maybe in baseball, but it's a good place to start. I don't think it would materially change the outcome if you did some things in the skew, but that's definitely something you could test. You could definitely assume, instead of assuming a prior of normal distribution and talent, you could assume skewed normal, whatever kind of distribution you want to look at.
Guys, let's talk a little bit more about what one higher level methodological question, which is this inability to distinguish the chance nature of the sport from the depth of the competitors. This is vexing in a way. You'd like to be able to do that. And I came away wondering if you needed a little bit more of an economist approach to, can you take advantage of some exogenous variation in the world to get some insight into that? So, for example, you've already mentioned the fact that Premier League changed over the last 100 years, and you have this fascinating graph in there where baseball and Premier League, Major League Baseball and Premier League looked about the same in the 30s or 40s. I forget exactly when, and then they depart radically with the Premier. I'm saying Premier League.
It was first division. It was first division up until 1992. People particularly here in London, want me to say that.
In particular, yes. Yeah, exactly.
Okay.
So that was actually a little bump. When they went to Premier League, it accelerates. This shoots up where you're seeing more diagnosticity in the outcome. And it seems that pretty obvious it has to be that's because the team quality is more differentiated than it used to be, because the sport isn't changing as fast. It just can't be changing as fast. It seems to me like that. Right. So can you use that in some way? Similarly, and I think less problematically, you have 4 or 5 European soccer leagues, and they show up similarly in your data, but not identically in your data. And they are playing the same sport. You can't believe that there's differences in the chance nature of the Bundesliga versus La Liga. I mean, maybe there is, but it seems like most of that variation that exists has to be coming from differences in heterogeneity of the quality of the teams.
Correct. And that was the basis why I wanted to do all the top 5 European football leagues. And I was also the rationale for also going back in time. So looking it back into the contribution of luck metric, if you show that it's time varying for a given sport, very time varying, that's one control, right? Given that the rules haven't changed that much. And then if you take completely contemporaneous, essentially the same rule set with fluidity across the leagues, that's another natural experiment. And I saw contribution to luck was varying there as well. And so and if you unpack it and run the analysis, you start to see these differences. Even though they're almost identical structurally, there are these differences in the depth. And part of that is the spending, the various caps that are, there's a lot of league dynamics that I don't, all understand completely, but there's a lot of, in like we're talking about salary caps in Major League Baseball. I think in Premier League, they have caps on the amount of losses you're allowed to have because people don't make money in Premier League on a given year. It's all made up in the capital value of the team, right? Ultimately. And so a lot of interesting league dynamics come through there. And you can kind of map back to that. And there's also one of the leagues plays slightly fewer number of games as well. There's a little bit of that noise in the background. But the nice thing is there's a really nice data set. The University of Texas professor catalogs all of these games all the way down to multiple divisions, going all the way back through time. And so it was really easy for me to download and run the analysis to see that when that kind of perfectly controlled. I thought it was a good control experiment.
For sure, for sure. Well, do you come away with a better sense of the chance contribution in the sport by that? Because throughout the paper, you're basically saying we're not able to say, which is
well. So the one thing, so what I want to, there's a little bit of a distinction between, and I think again, going back to the original inspiration, the Jody Newman paper, how do they define luck, right? So people use it kind of generically. Is it sample size? Is it this concept of competitive dispersion? So all the teams are the same, so it is a coin flip. But they actually introduced another parameter in the model, which is this concept of how they define luck, which is essentially the probability of an upset win. So it's like, what's the probability that an infinitely good team loses or an infinitely bad team wins, right? And so essentially what they're doing in the model is they shrink the Bradley-Terry model, which will give you your probability that the better team wins, back to 50-50 probability, right? And so in the model, there's another parameter they call alpha, the letters. So you have depth of competition beta and this alpha, which is the shrinkage parameter back to pure coin flip. So if the league was purely a coin flip, then this alpha per number, and it would be a number between 0 and 1, right? You're going to weight between the Bradley-Terry outcome and the pure coin flip. So econometrically, I thought it was a pretty cool way to diagnose it. Now, the problem when you go through all of this, and that was the point of their paper too, when you get in these very low competitive dispersion leagues, right, there's a lot of collinearity. And so I did a couple of charts where you don't really improve the model fit by adding this luck, the pure luck parameter.
Yeah.
And so that's why, I think why I'm leaning back to this competitive dispersion explains a heck of a lot in these sports. And it's a little bit less around what actually goes on in the sports. Now, I could kind of go a little bit on this concept of sports information ratio that I stole from the investment literature, which does tie in a little bit and is a bit more consistent with Mobuson's point. But, if you talk about the Bill James Pythagorean theorem, that parameter, it's sort of.
So hold on, Greg.
Yeah, I'm going all over the place, but we can,
bring me back. Let's do that because this is.
You're actually getting somewhere with that point, because one of the problems that when you've mentioned it several times, I'm going to make it really specific. If every team is exactly the same quality, then whatever determines the outcome of the game, it isn't skill. It's something. You can call it chance at that point, even if it's not an actual dice. We call that chance. And then as the skill gets a little bit larger, and that chance component roughly has to stay the same, then that's the only way you can sort of measure that chance component. But now the question you might ask is, and this is where Bill James comes into, well, what is it the thing that's causing it, right? So the sport that I know best is baseball, and I can probably tell you where that is. It's when you hit the ball at a certain angle and a velocity, and sometimes it's a home run and sometimes it's not, right? And you don't know why, and it could be because
you throw the ball and sometimes it curves and sometimes it does.
Yeah, and little things like that. I mean, it's not chance as in a dice roll, but it's something completely out of your control, and that's the thing that we can measure. And what Pythagoras is really not measuring that. It's measuring the dispersion of runs by game. And if you spread them out, you don't want to win by a lot. You only want to win by a little. That's measuring something different. But almost every sport now has something called X something, XG, X WOBA in baseball. I don't know if basketball yet has an X, which stands for expected. Sure. And the difference between those two is in some level what luck is trying to capture. And maybe we can actually measure that luck by looking at the difference between whatever X number and goals, X WOBA and WOBA. And I'll just talk about this because like Ben Rice right now in baseball, if the Yankees, I'm going to have to bring up a Yankee, it's my job, has hit a cover off the ball. And for the last 2 seasons, he's had the biggest differential between his actual WOBA and his X WOBA. And everybody was screaming, there's no way this guy is top quartile. This is a superstar. And we're just waiting for him to just regress back down to what we would call ordinary luck as opposed to bad luck. And that's kind of a way we can measure it.
Yeah, and it goes all the way back to FIP, like fielding independent, ERAs and those types of things, which I was going to use the example with clients. Like it's really about strikeouts and walks and home runs, and once the ball's put into play, it's a bit of a random outcome, right? And what do people control? So completely by I think, yeah, go ahead.
Also, the one thing, just because you brought basketball, I think the reason we don't have an X or expected thing in basketball is because the actual outcome happens often enough that you can just look at, like X is important in soccer, X is important, expected goals is important in soccer and hockey, where, you've got these underlying, kind of like peripherals that are predictive of it, but the actual outcome doesn't realize as often as you would like to. And so you want a more kind of smooth measure of things going on in the game, basically. Whereas
more
basketball,
valuable.
you don't need that as much.
It's more valuable, but people still use it in basketball. So, whether or not, in fact, the Cavs coach against the Knicks, after they were down, I think they'd lost 3 games, so they're close to eliminated. The Cavs coach is like, we're actually winning by expected metrics. And he means like, 3-point shooting. Some studies have said, conditional on the shot being taken and the degree of coverage is like, it's chance what happens once it leaves the guy's hand. And so they do use expected sum in that way. Greg had this observation, it may not be in the paper yet, but he's mentioned it to us on the side, that I think you guys will find interesting. I'd love to hear him say a little bit more about it. And it's how James's Pythagoras formula parameter shows up across sports. So before we do that, Greg, can you just remind our listeners what Bill James's Pythagorean theorem does? And so we can talk about this.
It's a way to translate runs scored and runs allowed, or goals scored, goals allowed for a team over the course of the season, and how it explains their ultimate winning percentage. And theoretically, if there's a big deviation, maybe that's due to random noise or luck, right? Either direction. Maybe the team got lucky in 1-inning games or didn't get lucky in 1-inning games. But it's sort of back to Adi's point about it's more the expectation over the course of the season. Run differential matters. And that's, again, back to my Massachusetts high school point. Goal differential is how you predict future performance. And so there's a way, basically the Pythagorean theorem translates, scales that runs scored, runs allowed into a number that maps to the winning percentage of a particular league. And so it does vary by league.
In short, expected number of wins given the number of runs you scored and gave up, or given the number of goals you scored and gave up. It's expected based on that. And there's a parameter in there that's vital. It calls it the Pythagorean because it's the square root of the sum of the squares of those things, right?
But for baseball, it happens to come out as a 2. So that's why, yeah.
Okay. So the exponent in that little formula. So this is classic Bill James. This may be the quintessential Bill James, which is like not sophisticated math, but it's deeply insightful and parsimonious. And now others have used that and people talk about it. And so so the exponent in his formula for basketball happens to be 2. And then you go out and find what, Greg?
Yeah, so baseball 2, basketball, it's 14, whatever the number. You can do this a bunch of different ways. But what I was feeling in this, and it kind of goes back to maybe our sample size argument about basketball, right? Or maybe baseball. Imagine baseball, they played, every game was 1,000 innings, right? So there's a little bit of the game unit itself has embedded, I think, different observations where NBA's got 100 possessions.
Yeah.
You're only getting 4 at-bats per, so there's a little bit of noise that comes across in the baseball. And so there's a lot of fundamental reasons why this parameter, and you can make assumptions about, is it a Weibull distribution or whatever, the run scoring mechanism. At the end of the day, think of this Pythagorean coefficient as a scaling number that translates runs scored versus runs allowed to winning, right? And ultimately, if you plot it, and if you do it for all the 14 sports, you almost get a perfect, what I first observed, this is completely empirical, then I was able to show it sort of mathematically. It's perfectly linear in what I call the sports information ratio, which is the mean of goals per game divided by the standard deviation of goals per game over the course of the season. Okay. And so I call it the high. So basketball, I'm going to quote this off the top of my head. Basketball is like an 8. And NBA and Major League Baseball, English Premier League is like a 1 or a little over 1.
And this relates to the information about a team's quality that you infer from their...
It's basically that game has a lot more, theoretically, that game in the NBA has a lot more information. So they play 82 games, and each game has a lot of information. So he kind of builds on that. But what I haven't done yet is build the unifying theory that if you do like Bradley Terry, I'm close, but this is just, again, me being an amateur, of how the competitive depth and this sort of sample size of the game or information ratio of the game come together to describe things. But anyway, if you do the math, you can kind of, with making some very basic assumptions, there'll be some scaling coefficient, but it should be linear in this information ratio concept.
Are you talking about the Sharp, almost like for a sport?
Well, so I stole this. Yeah. So we spend a lot of time in Sharp ratio, and philosophically, I know I'm going to be doing a little more rambling. I always felt like sports, it's always about point estimates. There's very little usually around uncertainty around parameters, and I live and die by the mean and the standard deviation.
Yeah.
So a few years ago at one of our conferences, I came up with a thought experiment. Which team would win or lose more games? A team that gives up exactly 2 runs every game, or a team that gives up 0 50% of the time, or 4 50% of the time? Which of those 2 teams would be better? And then you can do the same thing on the offense. He scores exactly 2.
Yeah.
And it was this whole Jensen's inequality, blah, 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 convex, concave. And basically you want a very unstable defense and a very consistent offense was sort of the method, but it only matters in low Sharp sports or low information ratio sports like soccer and baseball. You get the NBA, it doesn't matter at all. So that was I added another variable to the Bill James equation, and it loaded, but only in ways that would be consistent with the IR. And that made a nice story for my investors that you want to buy high Sharp ratio strategies. Risk management is much more important than low Sharps. So anyway, that's exactly the point.
And back to the paper, you're observing that this the exponent in James's Pythagorean is linear in the sports information quotient or whatever.
There's a scalar to it, but yeah, exactly. It aligns in the data. It's kind of a cool little paper.
That's neat, and that's only because you're able to look at however many different sports you looked at. I
just
cool
throw out something that our listeners should sort of know. If you just look at the point differential for every team, that is almost perfectly linear in their winning percentage. Not over the history of the game, because if you go to the periods of time where no one was scoring and you look at them massive, you need the curvature. But if you just look within a season, for example, at the winning the delta, your point differential for every sport, goal differential. Actually, I use points for soccer. It's linear in your winning percentage. It's very, very linear. I mean, and you can see where this comes from. You're looking at this ratio to a power is the first Taylor series. So first term is linear.
And then linear, exactly. And then what I can find that beta, the slope coefficient that takes that goal differential to map it to winning percentage, that's the number I'm talking about, will scale with this information ratio. Completely agree with that.
Okay, team, we should let Greg go. He's coming to us many hours ahead of us, and we've talked with him longer than we thought we were going to talk with him. But Greg, thank you for sending
Please edit anything. Yeah, of course. Thanks.
If our listeners are interested in seeing your paper, where could they find it?
So we've got, on this particular paper, it's not quite out yet, but the linear information ratio is out on if you just Google it, Pythagorean theorem, man group. There's also a Python package behind it. If you download it, you can run it. Advertises a bit on our ArcticDB, which is one of our database tools for Python. So,
well, speaking of that, I noticed in your footnotes that you grabbed your data. A big chunk of your data came from Neil Payne, friend of the show, Neil Payne, and sort of a co-founder of 538. And it goes all the way. The fact that that's there goes back to 538's founding philosophy. They decided right up front, we're going to use ELO for all of our stuff because it generalizes across sports. We know it's not perfect, but it generalizes across sports. But because they had that philosophy and Neil's maintained it, you were able to grab data and run this.
But if you are a friend of Neil, have him update for 2025. I had to do that myself. So,
well, he comes to the summer to campus to talk to my students every summer. He said that one of the tricks he talks to the students about is he's very good about keeping an ongoing log of every game that happens, so that for all the sports that he follows and he writes about, he's always updating his database just on a daily basis. So then when he's ready to run something, he just has it there. He doesn't have to do this.
If you guys want either the GM data, which I sent over, and that other thing, and also any of this game level data going back to the 1870s, I can, across those 16 leagues, I'm happy to share it if you need it.
We would love it, and I'm going to probably have one of my staff get in touch with you to get that.
Okay, Greg, we have lots
it'd be a fantastic tool.
Yeah, we have students doing projects all the time, and they would find that useful, I'm sure. And perhaps in some world, they might be useful to you. So, Greg Bond, thank you for being with us. Greg, again, Chief Investment Officer at Man Group. Man Group is a very large alternative asset management group. He is based out of Boston. He runs Americas for Man Group. He's also the PM, the portfolio manager for their flagship fund. Greg, great talking to you and good to see you.
Thanks,
Thank
guys.
you.
Good to meet you all. Thanks.
Interesting time of year, guys. Championship time of year. I think this is as many championships as we're ever going to see in the calendar. We are starting the NHL Stanley Cup Finals tonight. We've got the Carolina Hurricanes playing the Vegas Golden Knights. I'm seeing 58-60% chance on the Hurricanes. Shane, you've got something up there about their
Yeah, I think Mike was.
flirting.
Yeah, I mean the Hurricanes definitely are pretty heavily favored in this, but the Avs are really heavily favored against the Knights too. So what does that mean?
They've got the. I haven't watched for some reason. I was all about the Eastern Conference this year. I haven't seen as much from the West. But when I saw the West, who said this is? I'm going to show all my ignorance here, Shane. The captain of the Knights was injured for the first couple rounds of the playoffs, and he came back mid playoffs, and he's this big block of a guy. He does not look like a typical hockey player. He reminds me of, and this is another name I'm not going to have. Kentucky years ago had this Fred Flintstone square-looking quarterback playing quarterback. He was so much fun to watch because he was so differently shaped than the typical
Yeah, I
quarterback.
think you're talking. I mean, the first one you're talking about is Mark Stone, right?
Oh, Mark Stone, exactly. I think you have
Very
to like
Stone. He's like, if it's, I feel like he's like a rock out there.
you. I think he's fun to watch and fun to pull for just because he's so unusual out there. So and who's their little guy that's so good? Oh my God, the former Leaf who just looks.
Oh, Mitch Marner.
Yeah, Marner just different than everybody else. So there are some fun things about the Knights and the way they took care of the Avs. It's not obvious to me, but the Hurricanes did get that 10-day rest. They smoked the friggin' Canadians far worse than the outcomes looked. Anyway, that's
I mean, the Hurricanes have been kind of, they're I think 12-1 now in the playoffs so far. So they're kind of, I mean, if they were to, I mean, deal with the Knights in a similar fashion, this would be kind of his relatively historic run. I think the modern kind of, I put it like the Oilers in like the late '80s had one where they went 16-2, I think, in the playoffs. So if you're harkening back to kind of Gretzky era Oilers playoff dominance, you're doing pretty well.
Right. And they could drop one and tie, or they can sweep and get the modern record. This is pretty impressive. What about the NBA? The Spurs took down the Thunder in 7. That was a great series, back and forth, back and forth. Beginning of the season, we wouldn't have expected the Spurs, and now the Spurs are pretty big favorites against the Knicks. Knicks have looked great, but they haven't played anybody. These two teams. This was something like only the 8th or 9th time that the two best regular season teams played a game 7 in the NBA, something like that. So these are head and shoulders the best records coming into the season. It'll be interesting to see whether the Knicks.
Yeah, it reminds me a little bit about the back in the day when like the Lakers and Kings were battling back and forth in the West, and whoever was sitting there in the East was a little bit of an afterthought because did it really matter? I mean, I'm not.
Wait, am I right? The Knicks have a much worse winning record during the regular season.
Regular season, yes, but they've had a very impressive playoffs.
Yeah. Extraordinary playoff, yes.
The question is whether that's just a weak field or they've actually caught some fire. And of course, the big question is what are they going to do with Wemby?
Yeah.
Which would be
I mean, to a certain extent, them getting stomped by the Spurs wouldn't necessarily be evidence that they're not actually a very strong team. It seems the Spurs seem relatively unstoppable right now.
Well, I mean, I don't know whether there's any value to this, but the Knicks did beat the Spurs 2 out of 3, I believe, during the regular season. Does that mean anything? I don't know. Do we have a regular season for any purpose?
Right. It's so sketchy. It's really, I want to go back and look at the minutes that Wemby played, that kind of thing. The Spurs are bigger favorites in that championship series than the Hurricanes are. I think the Spurs are like 64%.
Yeah.
Fun fact.
The odds are about 200. They're about minus 200. So about that.
Guys, one of our listeners sometimes sends information about the ticket prices, and apparently you can get this off at ESPN. I haven't looked. I think this is like your typical get in the door ticket prices. So San Antonio is like the 19th or 20th biggest market in the NBA. New York's obviously the biggest market. What do you think the difference is in the price? I don't know whether it's average or marginal, but like ESPN will give you a ticket price to get in the door. What do you think the difference is? Like, what do you think the ratio is? But for the Knicks Spurs game, New York versus net games, New York versus San Antonio ratio.
Are we all supposed to decide now and then hold our numbers so we don't cheat?
Oh,
Go.
sorry. I'm going to just up and say 5-1.
I'm gonna just say what I think the numbers are. I would guess you can get in San Antonio for around $400, and I don't think you can get into the Garden for under 2,000. So that's
So you're
5.
a
Yeah,
little low on both. Your ratios are very close. The
yeah,
last numbers I saw were about 4,000 for the Garden
yeah,
and like 900, 890, 900
Yeah.
for San Antonio. So
mhm.
not quite 5, but in that direction. So y'all did good. Odd, your numbers were a little low, but y'all did good. Okay, that
Yeah.
kicks
I'm
off.
surprised you can't. I mean, is that the game hasn't started yet, so there might be an aftermarket
Yeah, God knows. I
reduction.
mean, this is
Yeah,
one observation from a couple days ago, but there's gonna this it's the same. This is the thing. It's the same matchup, just very
yeah.
different cost of taking it in person. All right, I want to do a little bit of college because this is an extraordinary week in college sports with a handful of things going on. So let me give you some rundowns. I'll try to find something interesting to say in a couple of these. I've got one especially interesting thing that for you guys, you baseball people. But I want to start with the men's golf tournament because I talk about this tournament every year because it's got such a cool format. They take 30 teams. They play regional qualifiers, I think 5 of them. They send 6 teams out of each to the nationals. That means 30 teams and some individual medalists arrive. They play 4 rounds of stroke play to cut it down to 18 teams, 8 teams, and then they go to match. Of course, match is where the drama is. Match is where the fun is. So it's like Ryder Cup style team match play, 5 guys aside, and that's how they're going to decide it in the end, and that's good drama. But to make sure they get the best teams possible there, they play 4 freaking rounds of stroke to get there. And so they ended that yesterday. They started match play today. How did they do to get the top 8? One of the fun wrinkles here, guys, is Mark Brody, who we had on like 2 weeks ago, 3 weeks ago. Brody has been involved with the ranking system. So you can look at what the seeds are of these teams, but you can also look at what their rankings are. The rankings, according to Brody's, of the final 8, 1, 2, 3, 5. So 4 of the top 5, and then 10, 11, 13, and 30. UCLA, the supposed 30th best. I have a lot of confidence in Mark's ratings. 30th best team in the country comes in. They land a spot in the top 8. So here's what they do. Today they play the quarters and the semis. So 4 match play team matches this morning, and then 2 more matches this afternoon to decide the semifinalists, and then the finalists go in and play tomorrow. So my Longhorns, number 2 team in the country, get a good draw. They got the 30th team. They got UCLA. They should whip those boys, and they got smoked. They got taken out. First team out this morning. Auburn's number 1 player, this Jason Coiven. I'm not sure I say his name right. He's like number 1 amateur, is turned down going pro. He lost today. They're playing the semis this afternoon. It's just good fun. Match play, team match play is great fun. But when I was poking around on this, I found some interesting wrinkles. Let me give you a couple of trivia questions. Who do you think has the most men's golf titles in NCAA history? They started playing them in 1897, apparently.
Can you give us, is it an older or like, are we looking at the first half of golf's history or the second half?
No hints. No hints. You have to suss it out
Okay,
yourself.
all right.
Adi, predict the home team. Yale dominated for like the first couple of decades. Even Harvard was smoked by Yale for a long time.
Yale, as if you go back to the 18 whatevers, you're going to
They
hear
did
a lot of Yale.
Yeah.
Yeah, a lot of football, a lot of baseball, even. The Yankees used to play at the Yale baseball stadium.
They haven't won a golf title since like 1943, but they still have more than anybody else. Princeton is like tied for 3rd, I think.
Right.
But here's a couple of runs that were just amazing. I came across Houston, University of Houston, won 16 in a 30-year stretch. They had this coach, it must have been a legendary coach, like from the 50s into the 80s, 16 out of 30 national titles in golf. And they were runner-up 4 other times. So 20 out of 30, they were one of the top 2. That's
amazing, because it's like you
ridiculous.
wouldn't necessarily think again about a coach having,
recruiting, maybe? Must have been ability to recruit.
Right. I mean, kind of
That's a great question.
a pipeline with that kind of success over 3 decades is pretty, given
Unbelievable.
I
Unbelievable.
want to raise this point here because we're talking about a long time ago. And you immediately went to the pipeline recruiting. I would guess that a sport in it at that period in its history probably is a coach is really going to take a mediocre player and can potentially make them quite good.
No, in
Um,
golf?
yeah, I mean, if you think about it, how much? I mean, if you think about the game could not have been as advanced in the 50s, 40s, 50s as it is even in the
No,
90s.
that's true, but we are talking 50 through 80s. 50s through 80s.
Yeah.
This is peak
50s through
Palmer,
80s is right. By the
Palmer
time you get to
Nicholas.
the 80s,
Peak Palmer Nicholas. So it's not unadvanced. But I lived in Texas through some of that era, and I knew a couple of U of H golfers, but I had no idea they had that kind of record. Anyway, the other one that jumps out, Oklahoma State. Get this, Oklahoma State is, I think they're right up with Princeton. They're like 12 or so champions. They have won a men's title in golf every decade for the last 7 decades. That's a different kind of streak, right? So now we've named 3 very different patterns, but they have been good and competitive and at the top of the game for a long time, but kind of regularly. And they're in the Final Four. They won their matchup this morning. I believe they won their matchup maybe they were going into, maybe they had them late. They were up big.
winning a Super Bowl in every decade or whatever. What they've had.
Who is that?
Are you going to tell me they're due?
One
Cade.
of Super Bowl in almost every 80s, 90s, 2000s, 2010s.
I'm trying to miss who you're saying. Who's I should know who that is. Who you're saying?
New York Giants.
The Giants? Oh God, I wouldn't have come up with that.
Yeah.
Oh yeah.
But then they're terrible the other 9 years.
Right, yeah, no, well, I mean, again, who knows what I don't know what Oklahoma's doing necessarily in between their championships. They could be tanking and then coming back. I don't even know. That's over 1 per decade is kind of, or at least 1 per.
Well,
decade.
they had a couple of 2s. They had won 3. I think in the 80s they won 3 national titles. Okay, let me give you 2 other sports. So baseball, y'all's love. They just finished regionals, and the Supers are seeded. The Supers are a Sweet 16 essentially. 8 teams are hosting super regionals. The cool thing about the baseball, both softball and baseball play the same structure. 64 team tournament with 16 4-team regionals, but they go through this weird cadence. I've told y'all this before. They do double elimination, and then they go to, at the Supers, they play 2 out of 3. And then in the College World Series, they first play double elimination, and then they play 2 out of 3 championships. So it's this weird iteration between double elimination 2-3, double elimination 2 out of 3.
And when they do the 2 out of 3, I was watching the college softball or whatever yesterday, and they do the latter 2 of the 3 as a double header. Is that correct? So is that all?
Those were elimination games. So we'll talk about that momentarily. But when they get to the final, that was just to make the final. So that was the last of the double elimination semis. And then the finals, they'll play, I think for the last 20 years, they've been playing 2 out of 3. Men's baseball, number 1 and number 2 got knocked out in regionals. So UCLA, Georgia Tech got knocked out in regionals. Okay, here's what I want to get to. Softball. So not because Texas is in the final, but we have been paying more attention because Texas won last year. They beat Texas Tech. They're again playing Texas Tech. And so we've been watching this thing since regionals, and it's just amazing to see a tournament get whittled down. And you'd never think your team's going to end up in the finals when there's that many teams, good teams. And the Horns are back. They came out of the losers bracket, won 2 yesterday against Tennessee to get into the finals. And then Texas Tech did the same thing, came out of the losers bracket, won 2 out of 3 against Alabama. Alabama, number 1 seed, SEC regular season champ. Tech is sitting there at number 11 seed. They win 2 in a row. Here's the thing though, guys, this is going to get a lot of attention. So Tech could easily beat Texas. And I don't know what the odds are, probably close to even, but they've got, remember Najee Kennedy, this pitcher that came from Stanford? Tech got her. They paid $1 million. She was this first big transfer in softball. This was 2 years ago. They got her, and as the first season she plays for Tech, they go to the World Series for the first time ever in Tech's history, and they go to the title game first time. And to remind you what happens in softball, a good pitcher can pitch every game. Pitchers sometimes pitch every inning of the postseason. It's not completely unheard of that to happen. And pitchers can be dominant in softball. And so it's a huge advantage. Okay, but here's the thing that's going on right now. This is completely crazy, and it's going to be a thing. It's going to be really interesting. There are rules. Have you watched softball before and noticed that they can pull a pitcher and they put the pitcher back in? Sometimes it's this jarring thing that happens.
A fielder was injured for like an inning, and then they came back in the game.
So there's this designated player rule where you can have a 10th person on the roster that's going to bat for somebody in the field, and it just gives them a little latitude in the way they move people around. And then around pitchers, they can pull them and then put them back in. And so it's not crazy. It's not unheard of that a pitcher might be pulled and then come back in later in a tight situation. They might start their best pitcher. They want to give her a break or whatever. They might bring her back in if the other person gets in trouble, but it's not super common. It happens, but it's not super common. Okay, the Tex coach, Glasgow, the Tex coach. So last year he had Kennedy, best pitcher in the game. They got a ton of NIL people and transfer people, and like 8 of the 9 starters are transfers in Tech, and they're the best offensive team in like years. And they've got Kennedy, and they've got another great pitcher, Caitlin Terry, I think is her name. So, and Kennedy's lefty, Terry's righty. Terry's also a good fielder. She can play left field. Kennedy can play first base, or they can sit him on the bench as a special designated player. And so what Glasgow started doing, and he talked about it with the players all season long and didn't do it. And then in the regionals, the super regionals, Tech is 11 seed, which means they're traveling for the super regional. They go to Florida. They go to game 3. And all of a sudden, Glasgow busts out this strategy of, I'm going to start moving, I'm going to start shifting. I'm going to platoon my pitchers against your lineup. Or if a person gets in a little bit of a trouble, I'll pull her and put the other one in, let her regroup, and then switch them back. And so he starts switching multiple times within a game. No one's ever seen it before. And he's got these 2 All-American pitchers, one lefty, one righty. And he wins that 3rd game against Florida. They get to the World Series. The other night against UCLA in an elimination game, he had something like 4 pitching changes in 3 innings, or 5 and 4, 5 and 3. It's like he was back and forth. He was literally.
But it's not like he was going batter to batter, and every time there was a lefty, he'd bring in like
not quite that much, but almost like that. Like if the lineup had a bunch of lefties at the end, he's going to make sure his righties in there against them. He even had one that I was watching where there was the big hitter for UCLA was going to come up like second in the order that inning, and she had already homered off of Kennedy twice. And he's like, by God, I'm not going to pitch Kennedy against her now. Let's get Terry in. He pitched Terry against them. She made it through a few of them, and then he put Kennedy back in. And it's just, I have to admire the innovation, and I mean, it's not quite rules manipulation, but it's complete novel.
Do we know how big the handedness advantage is in softball?
I knew for a fact that when I came in here and told you all these stories, you would ask me for some empirical observations that I don't have, and I do not have that one. It is the relevant question. It is the relevant question.
And I actually asked one about kind of the pitchers as well, because I was watching it too. Like, they kept talking about like a rising versus sinking. It actually is rising in this case, right? It's not like, rising fastball in baseball is a misnomer. A rising fastball just is sinking less quickly. But in softball, it actually, the distances and angles are such that it actually is rising, correct?
I don't know for a fact that's true. I don't know for the people think it is.
It looked like it. It looked like it on TV, but so does a rising fastball in baseball.
Yeah,
so,
right. I'm not going to say for sure. I know for rising fastballs don't rise.
I mean, I played enough softball. I mean, they can release it at a very low point in their body, right? And it can end up higher, but I guess it couldn't be arcing to get there.
Yeah, I'm just saying, based on the distance and speed, like, is it like on an upward trajectory when it hits the plate or not? It looks like it, certainly. But of course, in baseball, we all know that actually isn't the case. For, so.
And softball's like baseball in that they want the release to be the same no matter the pitch. And so they're not going to deliver a rise ball differently. At least they're going to try not to deliver it differently than the others. But I thought y'all would get a kick out of this pitcher strategy. I totally admire the innovation, even though it might be the downfall of Texas in the finals, for all I know. May not be.
It makes it like, in terms of pace of play, it makes me glad baseball does not do that to a certain extent. Like,
oh my God.
Like, I mean, they're crazy enough in baseball with the more restrictive kind of substitution rules.
Right. It's annoying as hell the way it is right now. I can't imagine it getting worse.
Well, I have been saying this for the last couple of years, but I really enjoy, and I'm sure I'm biased because Texas has had a good run in softball, but softball's fun. It's faster paced. Anybody, they have some big sluggers, but then anybody can hit a dinger. Like this little second baseman hit a game-winning walk-off the other day. It's just that doesn't happen a lot, but the risk of it is there on a steady
Well,
basis.
I mean, here's a question for Alan Nathan, our physicist expert. In softball, it seems, and I've watched some of the home runs, they often just stick their bat out and then it goes over the fence. It's
I don't think
incomplete
that's
swings.
true.
Oh yeah,
I don't think that's true.
I mean, and listen, they're using an aluminum bat, which is with incredible springiness, and their pitchers are pitching quite fast, and the ball is. I mean, I think it's an interesting question. I mean, how much? Let me make it fundamental. How much of the power in softball is generated from the batter, or the pitcher's speed? I'd love to hear that sort of broken down. I can tell you that in
I can
baseball,
tell you the speeds. The speeds. I don't know the batter part of that, but they report exit velocities during the games, and they're in the high 70s for these home runs. And the pitchers are pitching. Their changeups might be in the 50s, and their top pitches are 60s, and the top pitches are typically in the 70s. I think the Tennessee pitcher famously touched some high 70s last year, but so it's 70 in, 70 out. Roughly 73 in, 73 out. Roughly.
At 40 feet. Oh my God.
60. It's 60 feet, is it not? No, that's baseball.
No, it's 42,
40
I think.
feet. Yeah.
And with their stride, and at that distance, it is a softball, so it slows down probably substantially from hand to plate, because it's such a big surface area. These are lots of questions, but I can tell you that in baseball, the velocity does matter, but it's about 1/10 relative, matters about 1/10 as much as the velocity of the bat.
Yeah, right.
But these are aluminum bats, and so therefore
That's
a lot.
That's right.
It's a lot, much less. I mean, if you watch college, they use a different ball in college baseball than they do in major leagues. It has less bounciness.
Is that right?
Well, that's because the aluminum bats. I mean, they come up the bat pretty damn fast.
Yeah,
I mean,
right.
So
kill some people. Okay, why don't we leave it there? Appreciate y'all being up for a little college sports, minor college sports at that, but it's a fun time of year, and they have some creative tournament designs, which I think adds a lot of flavor. Why don't we leave it there? We missed Eric Bradlow this week. Enjoyed the conversation with Greg Bond, Shane Jensen, Adi Wyner. On behalf of the whole team here, many thanks for Dee Patel and Jacob Grodnick doing things behind the scenes, and Marissa Reyna making the bookings happen. Thanks to you guys for listening. Come back and join us next time. Between now and then, enjoy your sports.